So Gema is a senior Android engineer with 14 years of experience, a Google developer expert for Android, specializing in declarative UIs, architectures, concurrency, and observability. Passionate about sharing knowledge, Gema's hobbies include juggling 2 kids, a cello, and occasionally Android Studio when a new update is released. I see many instruments in your background, as well as some video game clues. So I'm excited for your talk. And whenever you're ready, go ahead and get started.
Yes, I am pretty excited to be today, to have been selected to be here and to come here to talk about test, which is something that is pretty important, and we'll see why. As I was previously introduced, I have been working for Android for almost 12 years. I have been working developing apps. I'm also a web developer expert. And currently I am working for a company called Cabify, which is a multi-mobility company. First and foremost, I want to again express my gratitude for being here with such a group of passionate individuals sharing their knowledge. And let's continue to the test part. So, well, as developers, we understand the importance of testing. For example, to validate app functionality, detect and fix bugs, to guarantee code quality and maintainability, for performance, security, reliability, and also to facilitate communication and collaboration within the team. For me, for example, reading the test that other people have written will make clear what the future does. So it's kind of an alive documentation. So it's cool. It's great to have tests. And now we are going to learn how to test to save the galaxy and our apps, obviously. There are a lot of qualifications, categorizations of tests. They depend on the topic they are based. For example, we could categorize the test based on their scope. They could be unit tests, integration tests, end-to-end tests. But if we categorize them based on target, we could have functional tests that we will test behavior or functionality. We will have regression tests that we will use to test the main path when something has changed, in case you have broken anything. And then we will have also smoke tests, which are kind of fast tests that are done over the whole application. So depending on what we want to test, which are and also depending on the target, we could have different kind of tests. There's also another concept which is pretty important, that is the test pyramid. The test pyramid will allow us to have a structure, to know how we can arrange our tests, how many of them should be unit tests, how many of them should be UI tests. So normally, generally speaking, we will have a lot of unit tests because they are easy to do, they are easy to run, they are faster, and they are easy to maintain because they usually don't change as fast as other kind of tests. Then we will have integration tests. We will see later what an integration test is, but we will have a less integration tests because they are a bit expensive, and also they are a bit slow to run. And finally, we will have less UI tests because for running UI tests, generally we are going to need an emulator or a device. They are going to be expensive. They are going to be slower, so we are going to have less of them. And if you see this pyramid, you will ask, well, what about the screenshot test? Well, it depends. We will see at the end of this presentation when I'm going to talk about the screenshot test, which is my idea of in which place we are going to put them. And there's also an important concept, which is the SUT. And what is the SUT? Is the piece of code, the class, the component, the group of components we are going to test. Okay, so it's that part that we need to assure that is working fine and is responding to all kinds of situations correctly. So it is the component or components we want to test. We are going to talk a lot about the SUT. There's also some predefined phases that a test case should have. These are two popular ways to organize the test case. There are other, but I wanted to bring these two. The 4-phase test, as its own name says, has 2 phases. The first one is the setup, where we are going to arrange everything we need to start our test. So if we need to prepare a dependency, if we need to prepare a variable or something, we are going to do this in that phase. Then we will exercise the test. We will do whatever we want to test. And then we will verify. We will see if the result of the exercise is the expected one. And finally, we have a phase called tear down, in which we will leave the system as it was at the beginning, because between tests, the state should be kept the same, because this will make them predictable. And then we also have the BDD style that is pretty similar, but instead of saying setup, it will say given, which is because it's using the structure given this situation, when this happens, then this should be the result. They are pretty similar. There are other ways to arrange the test, but it's important when you are preparing your test to know how you can structure them. And the last concept here is test doubles. The test doubles are going to be our friends that are going to help us to replace the dependencies of our SUT. So they will be objects, functions, or components that will replace that dependencies during testing, because we need to know, or we need to assure that they are going to behave in the way that we want them. For example, if I want a dependency to throw an error, test doubles will help me to make that error happen and then see how my SUT is going to behave. So they help us isolating the system under test, controlling the behavior of dependencies, and making our test more focused and reliable. There are quite a few of types of test doubles, so we are going through, now through them. This will be our example. As we want to save the galaxy, we will need a guide, and this guide is going to show us a list of the stars, categorized by constellations and with the distance that are within us and the star. So let's see how can we use the different types of test doubles. The dummy is just, we will use this type just to satisfy a dependency, but we are not here implying some behavior or some values or whatever. So for example, if I need a star in the subject under test, I will, and I'm not doing anything with this star, I will use a dummy. So it's just to fill that dependency. Then we have the fake. The fake, in the fake, we will create a new version of the dependency, we will extend the class of the dependency, and we will do whatever we want it to do. For example, in this case, we are going to fake the start API service, which will be the service that we will use to get the list of stars. And here we are going to have a method called getStart, and here we are faking the return of that method, and we are saying, hey, you are going to return always this list of stars containing Vega and Sirius and whatever. So that is what a fake will do. Then we have the stub. In the stub, we will do something very similar, but we are not going to create a new class or a new object. We are going to use a framework or a toolkit to say that when this method is called, I want to return this list. In this example, if for the getStart example, we are saying that when this method is called, we are going to return the list of these stars. We could also use the mock. The mock will allow us to check, to verify if in our dependency is being called some method or is being used some method, or even we can check if it is not called, because maybe we don't desire that method to be called. For example, in this case, we are verifying that the MockStar API service is being called and its method getStars is being called. And finally, we have a spy. A spy is a mix between a real object and a mock. So, well, and a stub is everything. So in a spy, you can decide to stub some of its method, and it will work as an stub. You can also verify if a method is called, and it also could execute the real method. Well, in this case, we are using a fake, but imagine that you want to use the real method of the component. You can, if you don't say the test that you want to stub it, you can use the real method. And now we are ready to save the galaxy or test. So don't forget your towel and let's go. We are going to start with the unit test. So a unit test will test individual methods or functions in isolation to ensure the correct behavior. We will use, well, it's not mandatory, but usually we will use a test framework, which is a set of tools and conventions to help us write them, organize them, and execute them in our code. In this case, the system under test will be a class or a method. If we have a big method, maybe we want to test that method to have a big set of tests for that method. There are some popular frameworks that we can use. JUnit is the most popular one because we have been using it from Java. And there are two main versions, which is Unit 4, which is the most used one. And then we also have Unit 5 that introduces some features that will allow you to write less. So for example, you can have parameterized and dynamic test, where you, in the annotation, you can say the values that you are going to expect, and then you don't have to write a test for every value because it will handle itself the assertions. So it's great, but Unit 4 is more widely used currently. And then we have code test, which is written in Kotlin. As always, have everything that is written in Kotlin has all the Kotlin advantages. So it's more idiomatic, it's also compatible with JUnit, but cannot be used to test Java code. And then we will also need to use a Stub or mock framework, unless we decide to dummy and fake all our dependencies. The most popular ones are Mockito, which I think is the most used one in Android, until we had Mocha. The main difference between them is that Mockito is Java-based, Mocha is Kotlin-based, and then we have in the middle PowerMock, which we usually use in the past because it allows some tricks to mock final classes, static method, but now it's not a problem because Mockito already has some support for that. Also, PowerMock now I think is stopping to be used because it has some compatibility uses with Kotlin. Okay, so now we said that the SUD is going to be a class. In our case, we are going to test this StarDataSource, which will be a data source to obtain that list of stars and also to do the search. That we have two dependencies. One is the API service and the other one is the dispatcher for the coroutines. So let's test it. Important, remember the phases. So we will have a phase named setup where we have to put the before annotation, and then we will set everything that we want to happen at the beginning of every test. So for example, here we are setting the main dispatcher, we are initializing the mock, and we are initializing our system under test. And then we also have the tear down function that will happen after every test finish, in which we will reset the main, reset the main dispatcher, and also clean up everything coroutine related if we need. And this is kind of an example. It's very important, I'm going to say it later, but it's very important to know that the name of the test should be as clear as possible, because when they fail, it's going to be the first thing you're going to see, and it could give you the first clue of the error that could be happening. So, for example, here, when the API returns a list, then the SUD or it should return the same list. So it's checking that if we receive a list of stars, then we will get a list of stars. And they are similar because we are not doing any mapping or something. There are also lots of tests we can do to complete this suite. We can check for error. We can check the search star by name method. Also check for error there. Whatever. So my recommendations here when regarding to unit tests are to write a small focused test with a single responsibility. If you attempt to test more than one thing per test, when it fails, you are not going to know firsthand what is happening. So you will have to rerun it again and see which is the assertion that is failing. So I will say that always try to write this test having just a single responsibility in mind. Keep test independent and avoid shared state. Use test doubles to isolate the component under test and to control whatever behavior you want the test doubles to have. Also, and very important here, is to test edge cases. Remember the pyramid in the beginning? You have to take the chance to test everything here. So test anything that could happen. And also very important, use descriptive test name to make it clear what the test is doing. Okay, and again, write tests for both success and failure scenarios. Let's go to the integration test. Here, we are not going to test just a component. We are going to test how several components are going to work together. So, for example, we could have the relationship between a data source and a repository, and we want to test how they behave together. It's very important here to name dependency injection because all here and also in the unit test, it will allow us to mock, to replace, to apply those test doubles easily. And this allows us to simplify this process, to setting up and managing the environment. Here I have put the most popular ones, which are Dagger 2, Hilt, which is based in Dagger, and also Coin, which is made in Kotlin. Regarding the instrumentation, because here when you are doing integration tests, probably you will have to test system-related stuff. For example, maybe you will have to test a database, or maybe you will have to test the UI. So there are some frameworks that will allow us to test system-related stuff. We have Espresso, which is widely used. It's mainly used, it's used for the UI. It has an easy-to-use API. I have put it like that. I will tell you after. I'll also have synchronization in the main thread. We also have now compose tests that will allow us to navigate the nodes and to do searches for compose. And then we have Roboelectric, which is not really an instrumentation framework because it's not going to use a real system. It's going to run in the virtual machine, but they are pretty fast. So, well, as a result of not running in an emulator or in a device. So they are quite useful sometimes. And as I was saying, Express is easy, yes. Well, it could be a bit verbose, but once you understand this, how to use the different methods, it will be easy. You just have to search for the view where you want to do whatever you want to do. You can search it by ID or by test. Then you can perform stuff over this view, for example, a click. And then you also can check if a situation is matched. For example, in this case, we are checking if this component, which is a checkbox, is checked. So let's talk about our example. In our case, our SUT is going to be a main activity, which is going to communicate with a main view model. And this view model has two dependencies. It has a get start list use case and a search start use case. So it's important here to have clear that we are going to test this main activity and main view model relationship. Well, first we will have to add this health Android test annotation. This will allow us to replace the dependencies for the ones we want to use. We have to also add the health rule, okay, to make that possible. And finally, we can, for example, in this case, we are going to fake the get list of a stars use case. Then we will have in the setup to call health rule inject, and then we can do whatever we want to do in the test. Okay, this is our fake. We saw, no, we didn't see that before. We see the service one, but it's pretty similar. It will provide a list of stars. And then here, for example, to simplify, is just getting the view and doing the assertion. Is checking that in the position 0 of the list we have Viga, and in the position 1 we have alter. Okay, so super easy. If we have compose, here what we are doing is to retrieve the list of star, and we are going to check that they are visible in the UI. We can also check the order in the list, but to make it simple, we are just checking that the stars are visible. So regarding integration test, my recommendations are write tests that focus on the interaction between components, because you will have a nice and great suite of unit tests that are checking the internal behavior of those components. So now it's time to check the interaction between them. Then keep them independent and avoid shared state, as we said before. Organize tests by the component being tested and their interactions, and also you will need instrumentation framework, so take that in account. Well, system test. We are making the cycle bigger. Depending on the target, as we said at the beginning, they could be functional, acceptance, whatever we want to do. In this case, we are going to test the whole app. So our system under test will be the app. And we will need here to replace backend. Usually our apps will have a backend. So here we have some options, which depends on the library we are using to do the request to backend. For example, if we use Retrofree or okay, HTTP, we can use MockWebserver. If we use Cator, we can use MockEngine. It will allow us to intercept whatever the app is attempting to reach in the backend and replace the response. For example, in the case of MockWebserver, we can create a dispatcher where if we are checking this endpoint stars/list, we are going to provide this JSON as a default response. Every time the app attempts to go to this endpoint, it will get this to this JSON. We can also set different response codes depending on whatever we want to check. And then we will have to create this dispatcher when we are initializing our test. And we have also to remember to start the MockWebserver because it will create a service in your device or in your emulator. We also have this robot pattern, which is a pattern used to simplify our tests because they tend to grow a lot, and also to make the code we use in the test more reusable. So to give an example, imagine that we create this robot where we are doing the enter search query. We are introducing a term to query. Then we are verifying if certain star name is visible, and then we'll verify if a certain star name is not visible. Then for our test, we can have something like that. It's very readable, and just having a quick look at the tests, you know what it's doing. You don't have to, navigate in these Espresso long sentences. So for the system test, my recommendations are to test user scenarios, things that the user is going to do. Also, you can test performance. So you can test, you can use the profiler, which is something that I recently discovered. And also you can use memory leaks detectors like Leak Canary. So they are pretty useful also for that. And what about end-to-end test? Well, in the end-to-end test, our system under test will be the whole system, the app and the backend. So here we have more work from the backend side to assure that there is always the same response when we call whatever endpoint. So backend has to provide an environment dedicated for this kind of test. But they are quite interesting because it will allow you to detect easily any problem if backend change anything in the contract or whatever. And finally, the snapshot or screenshot test, they will just capture the screen of your device. So I think they don't have a place in that pyramid because they complement unit integration and system tests. They will provide an additional layer of validation. So here, our system under test will be the view or the composable, depending on whatever you are using. There are several frameworks also, several libraries. We have shots that will need an emulator. Also, we have drop shots. They are pretty similar. And finally, we have Paparazzi, which runs faster because it doesn't use an emulator or device. It's using the library Android Studio uses for the preview. all of them also allows to have some error tolerance. So if the screen changes a little bit, it's not a problem. It's not going to break the test. And here is how you can use Paparazzi. It's super easy. You just have to tell it which is the device you're going to use to check. It has some predefined devices like Pixel 5, or you can also configure the device you want with the filters you want. And then you just have to call paparazzi.snapshot and take the snapshot of in this case, the composable. My recommendations regarding this kind of test is, well, first, be mindful of test maintenance. If the UI is something that frequently change, maybe they can become burdensome to maintain, which takes me to the second point, which is you have to remember to update reference images. You have to have a job or something in your CI that update these images that are going to be the images you will use or the framework will use to compare the new image of your app. And they are not a replacement, okay? They are not testing behavior. They are not testing other things. They just test how your screen is behaving. And you can take advantage, and this is quite useful, of this kind of testing to see how your app is being seen in several devices, different configurations, and that's quite useful. And we are ready to test everything. So let's test all the things. Let's automate all the things. And so long, and thanks for all the fish. Thank you. And now it's time for yourself to give your questions.
Thank you so much, Gema. I really loved all of your fun references that you had. I see some people are thanking you in the chat. Please, audience, if you have any questions, share them in the chat. I think I can get started with a question, though, Gema, especially with that last example you gave, but the snapshot tests. How do you ensure, just overall, how your test suite remains maintainable and efficient as the application evolves over time? Can you share that with us?
Do you refer to the screenshot test or
overall?
Overall.
Yes.
Okay, so, well, we usually run the test in every not commit, but merge request or pull request. So the way for us, for example, to assure that all the tests are maintained and are performing well is to detect problems at that stage. Sometimes if we see that a test is being, flaky, is failing, usually we search for another strategy for that behavior or for that part of the code. But I think the best strategy for tests are using them because they will realize, what is working for you and your team.
Yes, of course. Thank you. And I think your talk is a fantastic resource for learning more about testing, but do you have other resources like books or talks, tutorials that you really recommend for someone who learned a lot from this one but wants to dive deeper into the world of Android testing?
Okay, so there is a book. I don't know how it has aged because it has from 3 years ago, but it's called Android Test Driven Development by Tutorials, which I used when I needed to go deeper in the test part of Android, and it's the book I always recommend. So it's great because it includes from unit to integration, and then also have samples with the UI, with Room, if I remember well. So it's great.
Fantastic. Thank you. And I have a question here from Swati. This was earlier on in your talk, so I'm not sure if you covered it afterwards, but Swati wanted to know, what are some ways to measure code quality and code coverage based on covering requirements?
Okay, so
yeah, go ahead, Gema.
Okay, so from the side of code coverage, there are some tools. For example, well, in Java we have Jacoco that will make a report saying, the code coverage that you have. But I'm not very fan of the code coverage tool because they can be lied very easy. So you can have a result saying that you have a lot of test coverage, and then you see the test, and semantically you are not testing everything, or you are just testing to to increase that coverage. So I would say that in terms of coverage, what I do to assure myself that I am testing every corner is when I looking at my system under test, I will see if it has any kind of edge cases, errors that can be thrown, whatever, and attempt to cover that. Then regarding code quality, there are also some tools that you can use. For example, the linter, which is the first one that comes to my mind. Also, there are some good libraries like Detect, which will allow us to detect code smells. Also, you can set your own, define your own scripts and search for certain, some stuff in your code that is you don't want to be allowed. So I think it's also a good tool for that.
Amazing. Thank you. Again, thank you so much, Emma, for your presentation, for all of the great examples. I loved all of your references to Hitchhiker's Guide to the Galaxy, of course. Really appreciate everything that you did to prepare for today. And thank you, everyone, for joining us. This